Hi, everyone. Thank you for joining us today. So today we have we're very happy to have AR Pan Yi Cheng, right, who is the head of Produce Type 0 architecture as well as superstructure. So they do a lot of interesting projects in Singapore as well as around the world. And the most important thing is that superstructure has very good fabrication facilities. So if any one of you are interested to find out more, please come up with your questions so that both Yi Cheng and I can attend to your questions and hopefully stoke your interest in digital fabrication. So I'm just going to kick off today to introduce to you many different options of digital fabrication. So as you can see from these slides here, we have a very simple analog system. And then I will also show you some quick examples of milling, laser cut, and punch hole, and even back to an analog system again. So this was a very old project. I think it's around 14, 15 years ago when I was working in Brooklyn, New York for Rickenbacker Leong. It's a very simple wall structure. And what we have done is that we have come up with floor plans of different layers so that we can ask the bricklayer to lay them according to the angles. So what they do was they printed the AO drawings and they essentially just overlaid the bricks in that pattern, literally. And this is the end product. Okay. Then there's another kind of digital fabrication where we use CNC milling. So this was with SUTDAAL. It's called the Urban Microclimate Prototype. And essentially what we did is we wanted to create a climate prototype whereby there are embedded cooling tubes that influence the temperature around the surroundings. So you can see over here that these are all the CNC milled foam panels. And all these red and blue lines are actually the areas where we will score the protrusions, actually the subtractions for us to embed the cooling tubes. These are some of the process photos of how we have milled the structure. And then what happens is that we spray the GFRC over this to complete the structure itself. So that's one interesting way. I'm showing this, the Making Sense exhibition, because it was a precursor to one of our more high profile projects. So this is interesting in the sense that we have done a simple screen at the National Design Center, also again with the Advanced Architectural Laboratory. And so over here, we just have very simple kind of like a screen structure. This has no supporting ribs. It's a self-supporting, but of course, in a sense, we cheated by having zip ties to the ceiling, as you can see over here. Okay, so now moving on with this kind of technology. So what I want to have as a takeaway is also that for us practitioners, right, we are always honing our skills. So with that in mind, what we have done is we have done this Future of Us exhibition pavilion. I'm just going to fly through. This was a very fast-paced project. The design phase was probably around 4 to 6 weeks. The whole construction, whole design to completion was 6 months. It was part of the SG50 celebrations. We worked with Passage Projects, who were the brilliant structural engineers. We came up with the arches design. So what has happened is that we have concealed their structure within these aluminum panels. They are laser cut. There are 13,000 unique ones, but it's a very simple and easily achievable with the current construction knowledge then, whereby we just do a self-tapping screw detail to the secondary pillars. These are more details. In terms of digital fabrication, we have a simple labeling, which was done by our very good friend, Thomas Wortman, who is now a professor at University of Stuttgart. So he wrote this Python script, right, that allows us to both proliferate the surface with the patterning as well as unroll it into the cut sheets. Okay, so these are all the ways in which we have the different intricacies of the screens. So now I just want to zoom straight into fabrication, right? So as I mentioned, these are the self-tapping screws. These are the panels. They have all been labeled according to the system that we have set up. This is one way in which we try to mitigate any construction deviations. So we come up with this solution of brackets. This is the structure up close, the smaller scale one. These are the outriggers that we have to support the structure before the final center point piece is completed. And now you can go visit it. It has been converted into a permanent structure called Bayfront Plaza over here. So there's a nice little gallery inside here as well. Okay, so again, talking about how we use this technology, in my own practice, we have come up with this kind of a simple modular design whereby we try to replicate a similar kind of randomness, and using, again, Rhino Grasshopper, we were able to come up with all these three-dimensional drawings and the fabrication cut sheets. So this is a very simple bolt design with a racking system that you can just hook on. I'll come over to here. These are the panels whereby they are three-dimensional. They are all laser cut with a fillet design that we have learned, that I have learned from my colleagues from SUTD. So this is a very simple system. They just hook it onto the frame. That's the end product. And again, one of my projects with SUTD, this is a laser cut panel. To zoom in here, these are the ribs where we can configure according, again, from the digital twin model that we have. And then we made it into a lighting installation with our good friends from the Augmented Sensors Lab. Another project that I would like to showcase is this particular with Share is this particular project. It's a very fast-paced project. Last month, I have shared with you how to do this with Revit Dynamo. But with digital fabrication in mind, I'm just going to forward to this. So what we have done is for these custom patterns within the panels, these are, instead of laser cut, is with a punch hole system. And with the precision of digital fabrication, we were able to complete all of this quite quickly within 2 weeks. And this is the final product at the link between 71 Robinson Road and 63 Robinson Road. Okay, so back to the simple scale of furniture. What we have tried to design was to use Grasshopper Galapagos to try to optimize a particular kind of structure for a table that is as slim as possible. So what has happened is it has come up, we are able to generate different types that you can see here automatically just through the algorithm. And what is interesting is also that instead of carving it out from a particular block of stone, we were able to bend with it. So you can see over here, this is the rattan structure. So it's kind of like an analog, and then we plaster over it. And then our good friends are able to bend the marble over it. This is the end product. It's very slim, around like 2 centimeters. And this is the final end product over here. Okay, so that's it for me. As I've mentioned, what I was just going to show you all is share with you different kind of digital fabrication techniques. And now AR Pan Yi Cheng will share with you in detail of his 3 beautiful projects. So I'm gonna stop share now. And after he has finished his presentation, we are open for questions.
Okay, so over to me.
Yep.
Okay, thank you, Aloysius.
Yeah.
So I've shared some of these projects before, so I'm just going to share three quite recent projects that we have done. So before that, just a bit about our company. So I operate as three independent companies, but we work together on some unique projects. Produce started as a studio and a workshop doing design and make since 2013. And then after that, the workshop basically expanded and became Superstructure, which is a partnership with Emily from Penelop, a material supplier in Singapore. And then I started Type Zero Architecture, which is now working on projects in Singapore, Vietnam, and Indonesia. We are generally doing residential projects, but in Vietnam and Indonesia, they are more commercial. So as I said, the three companies have slightly different focus. Produce is doing design research, and we research anything from material to content and programs. And then Type Zero looks into typological transformations in buildings. And then Superstructure focuses on technological production, generally looking into digital fabrication, and we are slowly moving into additive manufacturing as well. So in terms of the overall area of work, we go from computation, fabrication to assembly, and they cover a wide variety of processes from form finding, parametric design, material optimization, parametric chem, fabrication, documentation, and finally assembly. So the new workflow is actually very fluid and non-linear, and we go between all these different stages all the time throughout the project. So as a company, we have this computational team that straddles across all three companies. This team works as a way of in all the processes of the project, from design to construction, but also it's a retainer for knowledge gain from all these projects. So I'll just show three ongoing projects that we have. So one of it is called the Sound Cave, and we have been working on this since 2017, 2017, yeah. And it is slowly becoming a product that we feel that we can now offer as a design and make design to production and assembly service. So the general idea is to look at masonry shell that they are kind of self-supporting and basically fit together modularly. There are several versions of this shell right now. One of the first one was an office space in Wisma. This is for Lin Foundation, and we wanted to create a continuous acoustic panel that can help reduce the amount of echo in the office space, allowing the space to be shared by everybody. It's like an open plan office, but then conducive for discussions. So the way we put it together is that the modules are in compression, and we use bolts and nuts to align them, and at the same time tighten them in compression. So this requires the use of our own CNC, 5-axis CNC machines to get the accurate angles out. And then they are simply pre-assembled in our workshop into vertical strips like this. And then during assembly, they are lined up column by column, and it naturally forms the arch. In terms of the material, it's quite thin. It's about 25 mm plywood as the core, and then we overlay a 6 mm birch ply at the top and an acoustic felt at the bottom. So it comes up to around 40 mm, which is kind of paper thin if you compare it to the scale and the length of the entire ribbon. So what is good about the whole process is that we can pre-design in even the services like lights and sprinklers. So the whole process of assembly will involve other trades, including the lighting, lighting installer, as well as the sprinkler installers. And finally, the finished look is like that. The white color part is the acoustic felt, and this creates a little small little huts like this for to identify the different cluster within the office. So it helps to give them identity in the office, contain the discussions within there, but at the same time, it feels like an open plan office where everyone can get together in the common space. So, so that was just for sound absorption. Then we, for a private project, we worked on this movie theater where it's not just sound absorption, but we have hidden speakers that are invisible. They are hidden by the veneer, and this acoustic room gives out sound as well. So in this space, it doubles up as a boardroom for the client for his meetings. So you don't see any speakers. The projectors are also hidden, so you get a very clean space. So at the time, we had a subframe to hold up all the panels, but gradually we started looking at a self-supporting structure here. And right now we have the ability to configure this shell structure to any kind of, most kind of spaces through our script. So what the script does is that it finds a kind of reverse gravitational computation to help it to become more structurally stable, and then making sure that each panel is completely flat. And then we will then assign the different type of panels from sound absorbers to speakers to standard panels, and they get modularized. So here is earlier on a kind of scaled model mockup that we did to just there's no glue holding this together, it's just like a jigsaw puzzle. And then we did a one-to-one just to understand the time taken to assemble it into its components. And then we started to script all the supporting components to create the acoustic panels. So we also scripted in the two paths for fabrication and the assembly process. So this is like one of our earlier experiments into the sound cave, and we eventually created this wall element that would curve around a structural wall on site, forming a wall in the guest room as well as an acoustic room for the client. So this was the on-site photos. So the dimensional accuracy is very high. We were able to really fit into the space, leaving enough walkway clearance. And the interesting thing is that the door is also like just snugly fitting into the whole geometry. So here you see the back of the panel where we will be filling with rock wool and expandable foam to fully seal this partition from the outside. And the final finish from the outside is in anodized stainless steel, and internally there will be a layer of upholstered panels. So this is actually the render, and the build looks like this. So I think so this was like version 2, and then right now we are busy building a completely self-supporting one. we are almost complete. And we imagine this to be able to like fit into different conditions, whether in interior space or in the future, we hope to explore it as an outdoor pavilion that also gives out sound. So it's good for events, and it can be easily taken down and reassembled. Yeah, so we hope to turn this into a product where we can work with different architects or interior designers to shape their acoustic spaces. Second one is we were involved in this research project that was supported by Design Singapore in this good design research grant. And what we wanted to do is to look at how we can turn regional plantation timber into building components that we can use in construction. So the regional timbers, they are of very loose fibers. So they are also quite fast growing. So the idea is to reconstitute them into a log instead of waiting for a big tree to come of age. We can harvest this wood earlier, use them as timbers, or we can even turn recycled timber into fibers and then reconstitute them through high pressure heat press. So this product is we are working on this in collaboration with OneWood, but our idea is to turn them into wall and floor panels that can replace RC precast panels. So the idea is to create this waffle that eventually we can vary how the waffle is organized in order to bring the load to different points where the load can transfer downward. So trying to create more design freedom where we do not need for a regular column grid. And earlier on in 2019, we had our first exhibition on this reconstituted timber structure. This was at Marina Bay Sands in the Arc Expo. But the clear difference is that this was actually milled. The pockets are milled out instead of being pressed into shape. So the next iteration, we will be looking at pressing the fibers into this varied form. So right now, we are working on a very standard panels just to test the feasibility. So the standard panels consist of a kind of egg crate structure in the middle, sandwiched by two pieces of reconstituted timber sheets. And it basically forms this lightweight structure that we believe can be equivalent in strength. So it would reduce the weight and increase the stiffness and strength ratio. So this is the mold. The mold is also made of the same timber since it has the same compressive strength, and therefore it can be reused a few times. And here you see that the press is actually pressing the fibers into shape. And finally, this is the completed, one of the first completed mock-up. And then we started load testing it to a point that is 1.5 kilonewton per meter square. So suitable for residential users. There are some fractures after reaching like 1.1, but we realized that it's due to some of the delamination in the kind of fabrication process, which we can iron out in subsequent fabrication. So we also looked at how the panels are joined together. So here we were kind of inspired by some Japanese drawing where you will knock in a piece to tighten two parts together, pull the two panels together. This is represented by the blue and red members that is hidden within the corrugation. So each panel comes in now 600 by up to, we can go up to 5 meters length. But in the mock-up that we did at NDC, National Design Center, it was 2.4 meter in length. We were also exploring the integration of services within the cavities. So here we see the fire retardant foam filling the spaces. And at the same time, we have some conduits so that wires can pass through. The exhibition has ended. Right now, we are looking forward to further this research and get more accurate tests done in terms of its impact strength and other meeting other criteria so that it can become a viable building product. So we see that the possibility for this is that there are kind of load-bearing wall and floor systems that will help to kind of maybe just simplify the building method into simple planes like that. So this is one idea for now, using reconstituted timber, and we are looking forward to be able to experiment more in the future. So the last project I will share is a plywood project that we recently was commissioned for an office space in Capital Spring. So for this project, it was mainly for a ceiling feature. The design was kind of replicating this bifurcating form, and then we try to recreate this as a ceiling feature. During the project, there was a lot of client inputs, and we needed very fast adjustments to turn around some of these options. And then the site was already being constructed. We were kind of just involved in the lobby area. So we had to work with a lot of on-site conditions, and this affect our curvatures in the design. And then the digital fabrication, we have to go through a kind of very rapid prototyping to computation process in order to meet the digital fabrication timeline. So the project is, as I said, is just at the lobby area, bringing people from this long corridor into the central pantry area, which is also the reception, and then kind of leading people into the office space on the left. So we did this with some 3D scan of the space, and then we had to control the curvature. And here it shows the curvature analysis. And then we have to relax them to allow for at least a more equal subdivision of the grid. And it helps also to kind of make it more structural. And here, this is the early experimental process, just to find out how bendy this birch plywood 2.2 millimeter thick wood is. And we normally test them not just for the joinery or the connections, but we often test them to failure to understand its limits, so that we can then input these parameters into our the computational design. And the structure consists of 3 layers, top and bottom, and the middle layer undulates between the top and the bottom layer to kind of make it like a structural space frame made of plywood. This image shows the strip sequencing, so that there is always an overlap in terms of joinery, so that you don't they don't join at the joints do not line up in the same across the whole feature. And we then have all the numbering. We also need to incorporate the sprinkler points, and the sprinkler are very specific in terms of where they come out of the feature. And these are specially cut and positioned so that we do not have a situation where the sprinkler comes out of an odd space within the structure. And then we also report in our script all the height points that is required to keep the datum aligned throughout the installation. During assembly, this is the templating that we will then lay on site. This helps with coordinating lighting and especially sprinklers. So in the templating that we lay on the ground, marks where the sprinkler needs to be, and the installers will try to match that point. And this is the whole CNC card file, and they are simply put together by pop rivets. Very lightweight, and it's quite quick to assemble them. And we only had weekends to do this because the office is already operational. So this is an image where you see the sprinkler coming out in the middle of two strips. And we took a lot of effort into aligning this. And final product is this kind of like a reed floating above the ceiling, leading you to the view out into the bay. And it helps you to kind of direct the traffic around the central island, which is the reception and pantry area. And we also work a lot with the air condition to actually cover up some of the bigger ducts, to mask some of the bigger ducts, and then the ones that you see here are the smaller one. There will also be LED strips hidden within the structure, and we are now working with the client to finalize the programming, and they can turn this into like a space for parties after work hours. Okay, thank you very much.
Okay, thank you, Yi Cheng. I have placed all of his studio's websites here for people in the chat group, for all of you who are interested to find out more about his work here. Now we will have our Q&A session. As what Wenwei has mentioned in the earlier sessions, this is just to come up with a nice get together for people who are interested in computational BIM. So feel free to join and view this video later on, which will be posted onto our YouTube channel. So Wenwei will also be sharing that link later on. So maybe I'll kickstart the Q&A session for Yi Cheng. So superstructure seems very cool. So I'm sure a lot of the people here are interested to find out like what are the capabilities of your fabrication facilities? Are they locally here, or it's a mixture of local and overseas? And yeah, what kind of capabilities do you all have at the moment?
Yeah, so the superstructure is located at Sungai Gadut, and we have a few machines. The main one is a 5-axis CNC machine, and then we also have a 3-axis one. These are basically milling machines. They can process timber material, aluminum material, and plastics. So we also have small 3D printers right now, but we are going to have a big wrap, which is a larger 3D printer. And slowly, hopefully, we are going to be able to acquire a robot, a milling robot, sometime late this year. So we are trying to combine our knowledge into in some of these processes together, and then get the relevant machines so that they can work together within superstructure. So however, the other than the machinery, the other product is the building information, like what you say, like what you call BIM, because we also have a project in the Middle East, and the fabricator is actually based in Ireland as for acoustic panel, and the project is a music hall in the Middle East. And so the BIM information is actually the final product that we send out to Ireland, and then they process it and have it built there. So anywhere else in the world, like as long as we read the same G code or have the same similar type of machine, we can do the simulation here in Singapore and then allow that fabrication to be kind of decentralized. Yeah.
Oh yeah, that's very cool. That's exactly what Woon Wei and BC Academy is trying to push for knowledge in Singapore, for us to be able to understand BIM and master it, and yeah, go beyond just Singapore. Any questions from the floor?
Yes, Moonway, I have one
Yes.
question. Actually, for this fabrication, right? So, besides the timber, any other materials, innovative materials that you are looking after? And beside that, for example, MET, mass engineered timber, is there any R&D or actual projects that you are engaging or exploring?
Yeah, so the problem with mass engineered timber now in Singapore, I feel, is that we need to import this all the way from Europe. A lot of them come from Austria, and the carbon saving that you are doing, getting through this employment of MET, get more or less watered down or kind of even cancelled out through the shipping process, which is also a major emission of carbon. So I feel that in the long run, we need to develop MET regionally. So that's why we went into a research of MET. And the way we can do this regionally is, I think, using reconstitution by putting together like either recycled timber, fast-growing plantation timber, or even bamboo, and turn them into one of the catalog of MET. So that's what I'm trying to do here. And the other thing is that a lot of projects here are quite small projects, and you want to discuss about like how do you do something enough to actually have a positive impact on the environment. I feel that instead of waiting for large projects to happen, it's more effective if we allow the market to the majority of market to start using MET in small batches. However, it's kind of prohibitive if everything is imported from Europe. So my goal is to create this reconstituted component in small batches to allow like even terrace houses and semi-Ds to be done in MET. So that there is a more widespread adoption, and I think this will have a faster and bigger impact on climate change. Right now, we are still in the R&D process, but we are actively proposing in some of our live projects. For example, right now we hope that we will have the first MET project in Sentosa for a private home. Yeah, but this is still from Europe. At the moment, we are not able to have all the certification done for regionally produced MET.
Oh,
I see,
yeah.
I see. So actually, you have a project in Sentosa now, because on our side, we also, beside this computational BIM, we're also looking into the possibility of 5G engagement. For instance, all your robots assembly, data, BIM, if it's connected to a 5G network, it would be seamless. So for instance, if you are using augmented reality robots, it can be have a better remote control of the machineries.
Yeah,
so this is the 5G trial now that GovTech is also pushing.
I see. No, I mean, we are interested to venture into this, and I think we have a bunch of really good stuff here that are all quite skilled in terms of computation. And
I see.
yeah, so actually a lot of students come out of universities with all these skill sets. So having started we started with a CNC machine in 2013, I feel like gradually we can actually become a place where some of these students can practice in. Because last time when I was in, overseas and even in Singapore, working for other companies, there is actually quite a lot of barriers in adopting some of this technology. So right now, that's why we are actively pushing for this, and we find every opportunity to include them in our live projects, however small they are. So the idea is that once we have a pilot example or prototype, then it can lead to more. Yeah. So yeah, definitely I'll be interested to look into how seamless all these technologies can come together, and we look forward to having a robot end of this year, and then we see how it goes. Yeah.
Oh, okay. So I'll reach out to you later. Thank you. Thank you.
Hi, this is Arnold from BCA.
Hi.
Yeah, thanks for your sharing, Yi Cheng. I have a question regarding maybe some of your research projects. Are you in collaboration with any institute of higher learning or university so far, or essentially your research is being done just within your own company, or your own team?
So I sit on the board of advisory board member of Singapore Poly built environment, architecture in the built environment. So we are looking at some elective programs right now with SP. Other than that, not with any other institution. So some of these projects that I'm working on, they are really like privately funded, like in terms of like, they are all live projects. So we just try to make like a little small research in every single live project we have. Then, when we have a catalog of small studies, we can then put them together to form a larger one in time. But yeah, no, right now we are not really in working with any other institution at the moment, other than SP. Yeah.
Yeah. Okay. Yeah. So so maybe, sorry for asking further, could there be any interest to work with like universities or other IHLs going forward, or the plan will still be just to stay focused on the collaboration with SP or internally?
No, we are open to any collaboration. Yeah, so actually we are looking forward to look at the building sector, and for example, we are trying to come up with a solution to replace brick walls, for example, for facades. This is something that we are trying to write small little problem statements, and then I don't know when the time comes, and I know, like, for example, NAMIC is also supporting some of this research. We may reach out to these institutions or universities and any bodies that will be interested to help us further our research.
Okay. Yeah. Thanks a lot.
Actually, maybe Arnold, since BCA is also like the governing authority, right? If you could also think of ways in which BCA can commission Yi Cheng's company to come up with like these solutions, especially BCA is interested in constructability and buildability, right? So the brick wall solution is definitely one in which you can save a lot of problems. You can make it efficient. Yeah, so maybe it's not just asking Yi Cheng about collaborating with IHL. Maybe BCA can also come in and help out a bit, in terms of funding, in terms of allowing TUV and all the testings required, right? Because for new materials, it's always about safety, fire safety as well, and the strength. Yeah.
Okay. Yeah, so I think definitely we probably need to organize a separate session to deep dive into some of these specific topics. So I mean, on one hand could be collaborations with IHLs, I mean, for funding or for whatever purpose, and also with some of our colleagues from BCA on how they can support you in some of your the specific use cases that you are driving.
Yeah, that would be great. Thanks.
Yeah. Any more questions, people? So we have quite a good turnout today. If you are shy, you can also type your questions in the chat group. We will verbalize and
actually, I have a lot of questions, but I should leave it on the floor. So yeah.
Oh, okay, I see some. What is the potential to scale up such non-linear design process? The DG Fab process seems quite time-consuming as well.
Yeah, so the scaling up, right, is that's why I'm looking at something that can start to replace concrete now. I feel that because I started with wood as a medium, it is very versatile, and it's actually the only renewable material that we know for building. So that right now, the whole focus of our company in terms of research is just to look at the current building technologies, and then we see which are the areas where we can intervene to either make it more productive, lower the carbon emission. And one of the key areas is to use reconstitute the timber, because it actually also has fire rating potential. And the interesting thing is that when you make a composite material, you test the whole composite panel instead of the material itself. So we can even achieve class 0, even though it's built of timber. So that is something that we feel that there is potential to scale up. So all these things that we are doing at the site in small projects, they help with sharpening our skill sets. And one of the key things is that I don't want to fall into the kind of cookie cutter in terms of what we have done in terms of prefabrication the last 10 years, where we just see container buildings. If we are able to do mass customization and open up a lot more design potential and freedom, then we should be able to develop more building, different kind of building types going forward. I mean, it's like a kind of a pipe dream, but I feel that it's just a way of moving towards that. So even though the small projects, they sometimes have difficulty in scaling up, but the things that we are learning from there, like the sequence of assembly, what are the things to look out for, like working with different trades, even knowing their ability to customize or not, helps us to eventually create a more complete product. Like I'm trying to put all the services together into a component, and the question is that possible? Can we really design building like a automobile where every part is designed and built just for that particular model or purpose? So that is like a long pipe dream, and doing all these small digital fabrication project, it helps in answering little small questions, but it's actually not that time consuming, because the computational process, it allows us like to set it up one time, and then it becomes a foundation and framework that we can then adapt to other similar solutions. So it is about building the archive. If you know what I mean, the time you spend on something will be increasingly lesser and lesser and lesser going forward. So it's about investing that at the onset. Yeah.
Yeah, I absolutely agree. It's just like one of the quick examples that I sent. When we did that exhibition screen at NDC, we sort of just further developed that intelligence to do the actual pavilion for the future of us. So yeah, it's the time spent is definitely well invested, and the expertise. Okay, so now we have one last question before we close for today. We already extended beyond. So it's from Mr. Lim. He asked, "Hi, Yi Cheng, do you encounter any issue with fire safety so far?" Very practical question.
For interior projects, a bit more forgiving. I mean, we have fire retardant spray that is applied onto the plywood wherever necessary. So when we work in healthcare buildings before, we would then completely avoid using timber altogether. And then we go to aluminium, where we use aluminium or steel. But in commercial building, as long as it's sprinkled, we always encourage the client to invest a bit more in having the plywood coated with fire retardant solutions, and that should help in small interior projects. Now the main thing is fire safety for architectural buildings, right? Which we are starting to come to terms with. So right now, if we are going to build a home for a single family house in MET, we have to sprinkle the whole building. That is something we are coming to terms with, and we are going to have it designed in. What we hope for is to meet clients who are supportive of this, and think of it as an investment for the future, for their kids. But if you think about it, the fire safety requirements in other countries, say in certain parts of Japan, they sprinkle at their homes as well. So it's not that dissimilar. Yeah, and looking at reconstitution, the product that we are using already is class 1. They are hoping to get class 0 certification. And then what we are trying to do as a composite material, it has even a higher chance that it becomes so-called non-combustible as a product. Then that will open up our ability to use them in different projects, even for residential.
Okay, so thank you, everyone. We've come to the end of this session. Thank you to Yi Cheng. Feel free to reach out to Yi Cheng through his websites, especially if you need some expertise for fabrication or even for design. You can see that he's an expert in fabrication as well as acoustic design. So I've posted a link for the YouTube channel where this video will be available. We will upload it. Feel free to subscribe. And also, if you have any friends that are in this industry and would like to learn more about computational BIM, you can share them the link. And then Wunwei will definitely add you all to the email list. So yes, thank you very much, everybody. So hope to see you all again next month. We will have another session again. Okay, thank you, Yi Cheng. Thank you,
Thank you.
thank you, Wei.
Thank you, Aloysius. Thank you, Yi Cheng. Thank you.